A few announcements. If you guys have lost anything, we have a collection in Lost and Found. Feel free to come by and pick it up if you can identify the item. Also, Ted, what? Oh, no brute forcing allowed. Ted is also recording all these sessions, so if you want a copy of this session or any of the sessions that you've seen so far or you missed, feel free to pick up a copy from Ted, which is outside of registration. All right, and with that, let's go ahead and get started with our first talk, No Budget Threat Intelligence with Andrew Morris, who is a security consultant with NCC Group. All right.
Thanks. All right, yep, so this is no budget threat intelligence tracking malware campaigns on the cheap. First of all, thank you guys all for being here at 10 a.m. after the ShmooCon party when you're all really hungover. Hopefully some of you guys are still drunk because it's gonna make this talk a lot more interesting. If you're streaming, then thank you guys for watching. Thanks everybody for coming in here. I actually wanted to give a quick shout out to the two people who almost got in a fight last night when we were standing next to the ashtray, and I like to think that one of them was like, "No, dude, AT&T syntax is so much better," and he was like, "What?" All right, so my name's Andrew Morris. I work at Intrepidus Group, which is part of NCC Group. My background is actually in offense. And this is, more of a defense-oriented talk. So I don't really have a ton of incident response or operations defense experience. So if I say anything that's stupid, or if there's anything that is not completely accurate or anything like that, feel free to shmooball the crap out of me or shoot me an email or whatever. This is my information down here if you guys want to follow me on any various social medias. So. That was fast. So basically the kind of rough outline of how we're going to do this today, we're going to go through a quick background, a little bit of info on threat intelligence, why you should care, a little bit of previous work that I've done in the same topic. We're going to talk about the infrastructure, setting up your no budget threat intel infrastructure. We're going to just quickly kind of breeze over that because I've actually done another presentation that focuses on that a lot more, which I'll talk about in a little bit. Discovery investigation, we're going to look at actually analyzing sensor data, honeypot data, securing malware samples, and doing a little bit of reverse engineering to look at the capabilities and look at some of the stuff that malware is talking to and things like that. And then we're going to talk about automation. We're going to talk about this thing called the Animus system, which is something that I've been building for a little while. We're going to talk about publishing reports, automated reports, mass scanning, automating mass scanning, looking for adversary infrastructure, and publishing signatures. And then defensive thoughts, we're going to talk about hardening machines, leveraging the data, how you can use the data that you collect, doing the stuff that we're going to talk about today, implementing firewall rules, sharing IOCs, and stuff like that. And then we're going to talk about roadmap for the future, some of the stuff I want to look at doing, how I want to grow some of the work that I've done in this space. So go ahead and start off the background. We're going to have a quick threat intelligence primer, set up cheap honeypots. We're going to examine attacks being executed on the internet. We're going to manage and aggregate data. We're going to locate malware artifacts. We're going to emulate the malware traffic. We're going to track DDoS targets. We're going to automate C2 discovery, and we're going to report some data. So, threat intelligence. What is threat intelligence? If you just break down the word, short word, threat refers to bad guys, and intelligence refers to predicting the future. So threat intelligence refers to studying bad guys to predict what they are going to do, usually to defend yourself, but not always. Conventional threat intelligence, a lot of the vendors who actually do this and aren't just random assholes giving presentations about it, they kind of study bad guys to develop IOCs, which are indicators of compromise, right? And IOCs can take a bunch of different forms. Basically, an IOC can go anywhere from like the MD5 of a file that is known bad, that's an indicator of compromise, or it could be a URL, it could be an IP address, it could be a domain name, it could be a registry key, ton of different forms that an IOC can take. A lot of these threat intelligence vendors, people who provide this stuff, they're gonna deploy agents on endpoints of their customer networks. It's kind of like AV, Like they're going to have sensors that are going to sit on desktops that are going to basically flag on anomalous behavior, like seeing an indicator or something like that. And once is bad, right? You get one flag, one thing that shoots off. It's like, okay, that's bad. It's not that bad. But if you get two or more across the enterprise, then that's what they're going to say is like, oh, this is like, really bad. It might be an APT or, whatever. And that's how it usually functions. And threat intelligence vendors do a lot more than that also. I mean, they, do a lot of big write-ups and reports and talking about tactics and procedures and all this other stuff. So, but why? What's the difference between that? I mean, antivirus, as they would say, is so 2005. It's dead. Everyone keeps saying that. Antivirus is dead. It's really, really easy. It's checking for a file, checking for the checksum of a file, and you can just change one byte in that, and it's going to change the checksum completely. So modifying binaries, it's really easy for bad guys to do. So AV is super dead. Threat intelligence is so 2015, right? It's really hard to change infrastructure. I mean, it's not really hard. It's hard to change your infrastructure a lot, and then it's really, really hard to change your tactics as a bad guy. I mean, if the products and if the people are actually looking at the tactics that you're using as a bad guy, you can't just change the way you operate in order to get around defenders anymore, or at least you're forcing people to. Today, the bad guys, the actual adversaries that I'm going to talk about, are bad guys that target the open internet. They just target everything that they can possibly see, because I don't do incident response. This was kind of the network that I had to work with. The bad guys we're going to be talking about are not terribly smart. They're not advanced. There's a lot of them, and they compromise a lot of machines. As it turns out, you don't actually have to be super advanced to compromise lots of machines on the internet. And they use really, really lame stuff like SSH default creds, JMX console, like open JMX consoles, shell shock, MSO 067 facing the internet, whatever. We're not talking about these people. We're talking about these people. So it's a spray and pray, basically. It's like Modern Warfare 2, It's the numbers game, try to pop as many boxes as humanly possible. Miss 99.9% of the time. So again, the TLDR of infrastructure. We're going to talk about honeypots briefly, right? So raise your hand if you know what a honeypot is. Okay, about almost everybody's hand just went up. That's good. I was giving this talk, I was giving a very similar talk to this elsewhere, and I was like, okay, yeah, like, raise your hand if you know what a honeypot is, and literally nobody in the room raised their hand. And I was like, oh god, this talk is gonna suck so bad for all you guys, I'm so sorry. So yeah, in case you aren't aware, a honeypot is a box that serves no business, it's a machine, or a service that serves no business purpose whatsoever. Its only job is to attract the attention of bad guys, right? So in terms of infrastructure, like I said, we're going to kind of breeze over this a little bit because I have another presentation that talks about this a lot more in depth. But basically, I set up lots of cheap honeypots that are sitting directly on the internet. I used a lot of Kippo, and I'm going to talk about that in a little bit. Some Dionea, which is another type of honeypot. And a bunch of empty Apache servers, which actually, believe it or not, are really cool because they're going to collect logs on just people that are just blasting the internet, looking for the presence of a file, or looking for shell shock, or looking for a bunch of stuff like that. I'm talking about centrally managing and aggregating the data. Something that I use is called MHN, which is Managed Honey Network. I'm sorry? Modern. Oh, I'm sorry, Modern. It's probably, you probably wrote it, didn't you? Modern Honey Network. I'm sorry, I got to go back and fix that. It's developed by ThreatStream. It's awesome. And then I'm going to talk about some like stupid cheap hosting. Cloud at Cost, if you guys aren't familiar, is a really awesome company that you can rent just stupid cheap VPSs with. You can get them for $1 a month, or you can get them for $35, one-time fee, and you have them forever. Can confirm, have had Cloud at Cost VPS for like 2 years that I paid $35 for like 2 years ago. So now I have like 30 of them. It's awesome. And so, yeah, and then there's also like AWS free tier, which you can get, I want to say maybe 5 of them or maybe 4 of them, and you pay nothing. And they're these like, cheap little low performance VPSs that sit on the internet that you can do whatever you want with. So if you want to set up whatever, like, 10 sensors for $40 a year, you can get 5 Amazon free tier boxes, 4 or 5 Cloud at Cost boxes, and you've just paid $40 for 1 year of having 10 servers that sit directly on the internet. They might not have the best performance in the world, you know, because they're free tier and they're cloud at cost, but honeypots don't really necessarily take up a lot. They're not super CPU intensive or anything. They're not really going to be doing anything crazy. So talk about Kippo a little bit. I use lots of Kippo. Kippo is a medium interaction SSH honeypot. Medium interaction basically means it sits between low and high interaction. A low interaction honeypot could be classified as like something that just sits there and it just maybe looks at things that are port scanning it, right? Or anything like that. It doesn't actually emulate the service at all. Or maybe it even gives like a banner. A medium interaction honeypot is going to be something that's basically going to be like, you know, Kippo basically is a great example because it emulates the service itself, what a SSH client is used to looking at. So it's kind of tough to tell, like, is this a honeypot or is it not when you're just looking at it, because you're actually interacting with it, you're typing commands, you're authenticating, all that stuff. And then a high interaction honeypot would be something that's like, it is an actual, like it is the code, it's not emulating, and then maybe it's just ephemeral, maybe it goes away once the bad guy logs out or something like that. Kippo logs bad guy terminal sessions for playback, which is really, really cool. So when a bad guy logs into your Kippo session, or logs into your Kippo instance, like trying to, you know, do bad stuff or whatever, it actually records the TTY log, and you can play it back. And sometimes it's hilarious, because sometimes the bad guys have no idea what they're doing. It's like you'll see them like type a command, and then it's like the command will fail, and you'll see them like pause, and then you'll see them like type another command, like backspace it, and then they'll type another, and you're like, all right, man, come on, get it together. You can configure what credentials you want it to allow. It comes by default. There's like one password that it allows that will let bad guys in. You can make it allow any password. I actually haven't done that. That's hilarious. I should do that. You can have it, you can set up a list of, you know, like 5 passwords that you want. And sometimes you do have to be careful with the passwords that you want it to accept, because sometimes bad guys will actually not use really, really, really easy passwords, believe it or not, because it's like, or if there are more than one passwords that are accepted on a box, it'll know that it's, the bad guys will know that it's a honeypot, and they won't execute any activity on it, which is weird, but that's what they've started doing recently. It will log, the things that Kippo logs are, it's going to be the username that somebody's trying to authenticate with, the password, the source IP address it's coming from, and the SSH library version. And then once attackers actually get into Kippo, it hooks a fake, or it has a fake wget command or whatever that actually hooks like an HTTP GET request or whatever. So if a bad guy logs in and tries like wget a piece of malware or something, even though Kippo is like a honeypot and it's not actually real, it will still reach out and grab that malware sample and pull it in so you can analyze it later. Unrelated, I actually wrote a Metasploit module which identifies Kippo instances externally, and I don't think this has been fixed yet. So you can still identify, which is funny because like that's something that bad guys should do, but they don't. And basically, it's probably going to be fixed here pretty soon. But anyways, so I did some no budget illustrations in MS Paint. This is because I don't have Photoshop, and I kind of wanted to stick with the theme. So this is your machine talking to a honeypot. This is you managing a honeypot, and then bad guys going to be attacking the honeypot. This is like, you know, really entry-level balling on a budget. You know, you got one honeypot, you got your box, you log in, you look at attacks that people are doing, and that's just kind of how it looks. And then MHN comes in, which is really handy for a number of different things. Yeah, managed, it's modern. That's wrong, sorry. Developed by ThreatStream. The developer is awesome for answering all my dumbass questions. It's open source-ish. It's actually open source. You can still download it and implement it, but it's a little bit different. They have a pay model. It allows you to deploy honeypots really easily. It's got like deployment scripts that you can just paste into your box when you're configuring them, and it sets everything up. It's super duper easy, and it'll configure it in like 5 or 10 minutes. It aggregates the data for you in a Nimacine, whatever, database that sits on top of MongoDB. So if you have 10 honeypots that are all configured to use HP feeds and talk to an MHN instance, then it'll aggregate everything together, and you can query it kind of centrally, which is awesome. The API is awesome for it. It's not documented currently, so you have to like literally read through the Python code, or in my case, just email the developer until he emails you back, which he does. He's getting sick of it, but he does. And yeah, NemoSign is awesome. It's something that somebody else wrote that basically sits in between. It expects HP feeds data, and it writes it to MongoDB. It's really cool. It looks like this. I took this like an hour ago. So usually those little flags there are, those little question marks are actually the country's flag of the originating of where the IP address is originating from, what country. In this case, I'm getting hit a lot by this group in Hong Kong, but for some reason, the geo data doesn't report that it's in Hong Kong, but it is in Hong Kong. These people are crazy. They'll hit you with 200,000 attempts per day. It's actually nuts. A couple of gotchas about MHN. I really recommend that you update the deploy scripts so they have more stuff, like include your own SSH public key or a SSH public key for it to trust. So update the host name, have it install packages. Like you can update all this stuff in the deployment scripts, which I didn't realize for a long time. MHN pulls threat stream forks of popular GitHub repos by default. So if you want to use MHN to deploy a Kippo instance onto a box, then it will pull from the threat stream fork of Kippo instead. So you can consider forking your own repos. I've actually just done this recently, so I can update Kippo and I can update the version that it pulls, and I can add my own stuff, and I don't have to worry about doing it after the fact. And then also some other things. I try to make a habit of maintaining a safe list, like a white list, that if I'm testing my honeypots or whatever, and I don't want my good my benign data to contaminate otherwise like 100% attacker data, maintain like a safe list of like the IP addresses that you're coming from or whatever, so that you can grep-v that later or suck that out of the database or just whatever. So after implementing MHN and some other stuff, my no budget threat intel stuff is kind of more blown up to look a little bit more like this. We've got untrusted honeypot. Yeah, we've got more no budget architecture diagrams right now. Didn't use Visio because I got no budget. I used MS Paint. We've got untrusted honeypots that are sitting out there on the internet. They're all centrally talking back to a semi-trusted MHN instance, which it's semi-trusted in that I still don't have anything that's on there. It's like, you think of it like a DMZ almost. And then behind that I have my trusted machine, which connects to that. And I do actually trust the machine on the bottom. It's configured with a password that I actually use and things like that. And then my machine connects to the trusted machine. Everything sucks logs over. So you can assume that like if a honeypot just blows up or gets completely compromised, doesn't matter. Like you don't trust any data on it, you're not losing anything, and so on and so forth. If this kind of stuff is interesting to you, just the infrastructure itself, see the Ballin' on a Budget talk that I did at B-Sides Charleston. So we're going to talk about discovery and investigation. Bad guys are still using shell shock to propagate pretty heavily on the internet. You're still going to see a good bit of that. It's still working. There's still a bunch of stuff that's not patched for that, believe it or not. If you want to start no budget threat intel tracking bad guys that are propagating with shell shock, just look at all of your Apache logs and grep for the standard shell shock characters that you're going to see in a shell shock request, and the standard thing like that, which is right here. And then, so I discovered a couple of groups that are still propagating with shell shock, with a lot of bots that they're using. One group in Russia, one group in the Netherlands. But mostly the stuff that I look at is SSH because it's super duper duper common on the internet. There's a lot of SSH that's facing the internet. There's a lot of SSH that's configured poorly. A lot of really bad credentials that are being used, and so it's obvious. It's a number one kind of choice for bad guys to use. Bad guys try lots and lots and lots and lots of passwords on the internet. There's a group in Hong Kong, I was actually just talking about them earlier, that I've seen over 100,000 authentication attempts per box per day from them. So they'll literally just sit there and just try to authenticate with, like everything, whatever. And then this is the range that they're coming from. If you ever feel like checking your SSH logs or anything like that, I guarantee you 100% you're going to have authentication attempts from them. And the thing is, like, you'll look at the passwords that they try, and like, yeah, they do like password 1, and they do, you know, password 1, capital P. They do that stuff, right? But they actually try like some really, really, really advanced, crazy passwords that I'm pretty sure have come from password dumps from elsewhere, or they just are actually banking on doing brute force attacks that are like real, actual brute force attacks. Like, they're just going to keep on doing it forever. Usually the stuff behind the SSH people is just automated scripts. You don't really see actual operators too often log into Kippo instances. It's usually like something will log in, run an automated uname-a, wget a piece of malware based on the output of that, and then it'll execute it or whatever. But you do still get actual operators that, you know, because obviously that's not going to work. And so then sometimes you'll see an actual person, a human being that logs in and actually checks like, oh, what's going on here? I've gotten a lot of really, really cool SSH data. So this is, I mean, it's a numbering of, this is the passwords that people actually have been trying. I've seen 24,000 instances of people trying root as the password and so on and so forth. There's a bunch of SSH library versions that people use as well. The most common is SSH-2.0 PuTTY. That's kind of a weird statistic here just because that is actually just what the Hong Kong group that I've been talking about uses. It's not actual PuTTY, it's just whatever the brute forcer that they wrote, they configured it to use that as the banner. You can think of it kind of like a user agent. But the funny thing about this is, or a funny thing is, like, you'll see the names of hacking tools in the library versions. It'll be like SSH-2.0 _ Medusa, and you're like, that's definitely not a regular remote administration tool. A couple of SSH gotchas. So bad guys love using SFTP, and Kippo doesn't include SFTP by default. So if they try to negotiate an SFTP session or whatever, it's gonna fail by default, but some guy who's a lot smarter than me wrote an SFTP patch. So you can incorporate that into your honeypots, and you will get so much more malware when you do that. A lot of people log in to do wget, but bad guys are gonna wanna just do it in line with SFTP. So I actually forked over a version of Kippo. I added an SFTP patch, an option to disable this weird fake jail that Kippo does, which I hate. I added some more default creds, and I got rid of the port 80 wget limitation that Kippo has by default. And the reason the developer put a limitation on Kippo was because he didn't want people using Kippo instances as port scanners, but like, I don't care, I'd rather get more malware. You're gonna see a lot of this when you start doing this. You're gonna see a ton of these like HFS web servers when you start looking at attacks like this. They're all in Chinese, of course. And you're gonna see like the file name, the size of the file in here, the date uploaded, and the amount of downloads, which is important because that can let you track how big a botnet may be. If you see that something was uploaded 3 days ago, and you see that it's got 9,000 downloads, then you can usually say, okay, these people probably have 8,000 to 9,000 bots sitting on their thing, just from this as a source. And you're going to see a ton of these. I mean, they're everywhere. Like it's like this one version in particular. Like bad guys just love this stuff. I don't know why. It literally does the same thing as Apache, and it has directory listing enabled by default, so if there's 1 sample or 10 samples, you can get all of them just as a result of getting access or seeing the path of 1. Oh, hang on, I think I just did that. So some no-budget tactics for this kind of stuff, if you want to find more of these. You can Google dork for these web servers. Google's weird about indexing things that aren't on port 80 though, so that's a little bit difficult. In-text HTTP file server, you can look for that. If you feel like grotesquely violating the Computer Fraud and Abuse Act, HFS is vulnerable to a really bad RCE bug, and no one ever uses the updated version. So if you do feel like being a criminal and executing code on their boxes or whatever, you can. There's an exploit for it. It works. So reversing these samples is a talk in and of itself. Actually, like reverse engineering the malware samples that you find. And I'm not the best reverse engineer, so don't listen to anything that I say about it. If you're also bad at reversing, check out malware.com or VirusTotal, because they're 2 malware sandboxes. Malware is awesome. Malware.com is awesome because they don't share anything unless you let them. VirusTotal has a cooler, prettier engine, but it will share your stuff. It's owned by Google, so you can put 2 and 2 together. Yeah, don't be evil. Don't be evil. Reversing, so I was getting hit a lot by one particular IP address, hitting me a lot, hitting a lot of my sensors a lot, using a lot of different passwords, whatever. They were getting in and trying to pull a lot of malware, so they were running a pretty big campaign. They guessed one of the scripts or whatever, guessed one of my good passwords that I had configured, and they logged in and they got a malware sample, so to speak. The same web server that they were grabbing it from had directory traversal. Obviously, they were grabbing an ELF binary because it was a Linux box, but I noticed that that same web server had directory listing enabled, so I grabbed all of the malware samples that were on there. One of them was a Windows, there were a couple of Windows samples, and so I ran it. I was doing some manual reversing, and I found that it was passing a ton of IP addresses in ASCII, which was weird, over this custom binary protocol over port 36,000. So these IP addresses that were being passed from the C2, it was reaching out. I was executing malware on the machine that I was analyzing it on. It was reaching out and trying to talk to the C2, and the C2 was just passing this weird binary protocol back. It wasn't IRC, it wasn't HTTP, it wasn't anything like that, and in it was a bunch of IP addresses. And those IP addresses were DDoS targets, and so, you know, that's pretty standard. You know, it's reaching out, and the server is just giving it back, hey, here's all the DDoS targets. We want you to DDoS this box, we want you to DDoS this box. And it was sending that out to all of their bots. So the C2 was architected to pass this to everyone, and that's, I mean, if I wrote malware, that's not how I would do it, but I guess it's a good thing I don't write malware. The bots receive the IP addresses and they start spraying traffic at them. If you reverse the malware samples, you can actually find the function names like synflood and, you know, UDP flood or whatever. So at this point, I'm like trying to reverse a bunch more stuff. I actually hit up, if you have ever seen him on Twitter or anything, Malware Must Die, which is either a person or it's a group of people. All I know is that he is insane, and like I hit him up and I'm like, hey man, can you help me reverse some of these malware samples? And he's like, yes, send me all of them. And I was like, all right, okay, dude. And so he helped me, like, you know, reverse a bunch of these malware samples, and I was like, dude, this is awesome. Like, can I donate like 20 bucks to you guys at PayPal or something? He's like, no, we don't do this for money. We do it because we hate malware. I was like, oh my god. All right, I wish I loved anything as much as you hate malware, man. I was looking at a bunch of the material that he was publishing, and I saw this. He published this video of like all this like crazy stuff that he does, and this was a video of him like recording a screen session, a screen sharing session of one Chinese operator training another Chinese operator how to use a product that he had developed and sold him, which generates ELF binaries and then has like the C2 package and all that stuff. And I don't know about you guys, but I don't speak Chinese, but I did notice in there, a little bit closer, bottom right, the port number is 36,000 by default. And I was like, huh, I bet that's the same family of malware as this Windows binary that I found. And I'd actually been seeing other things that have been speaking the same protocol or whatever. If you have a copy, by the way, if you already know what I'm talking about and you know where this is going, if you have a copy of this software, I would love for you to send it to me. I've been trying to find it everywhere. But I want to buy it from the Chinese dude because I'm like not trying to be on watch lists and stuff. So I realized that this C2 is one of lots of different C2s, and I fingerprinted the C2 network service, and I wrote a scanner for it. It's on my GitHub page. I wrote an NSC script for it, but I don't actually know Lua, so I mean it works. It gets the job done if you want to use it. I stared at Wireshark for what felt like an eternity, and I basically built a scanner that logs in. It logs into these C2 servers, and it reports back to me all of the IP addresses that it's currently targeting. It turns out it's actually really hard to write a client for a server that you don't control. Because like I'm trying to write a client for this malware C2 thing, and the server's like going up and down, and like it's using a protocol I don't understand. I had cycled through a couple of different C2s to actually like write the client out. It's like trying to learn Spanish when you got two Spanish dudes in the room with you, but you don't know Spanish, and they're just talking Spanish to each other, and then they keep walking out, and you have to go and find more Spanish dudes. That's basically what it's like. But yeah, I wrote a scanner. I was going to demo it, but I actually, all the C2s that I'm looking at right now are down, so I couldn't, but this is a screenshot of what the scanner looks like. It logs in, and it pulls all of the DDoS targets. And so I guess the reason why this is important is because it's really cool as an outsider or as someone running your no-budget threat intel organization or company or whatever, you can actually see who these bad guys are targeting, which can be cool for a number of different reasons. You can see who they're sending out the DDoS attacks to. It can help you in identifying who they are. It can help you make the world a better place. You can warn them. You can you can do a lot of stuff using this information. And there's 1,000 ways that they could do it better, so you couldn't, but they don't. Thank God. And so I'm going to talk about kind of automating a lot of the stuff that I've been talking about so far. I'm building this thing called Animus, and it's kind of an automated threat reporting system. That's a fancy word for a bunch of like cron jobs that sit on top of shell scripts and parse data and stuff like that. But I'm building this thing, and it's basically taking the sources of all of my data, it's aggregating it in a certain way, and it's publishing it out for everyone to look at for free. And this is the GitHub page. I literally just put this up yesterday. I've got a lot of data. It was on like a development branch or whatever on my GitHub. And so I changed it to an actual like an organization GitHub page as opposed to like mine. You can find it at github.com/animus project. Currently, I'm only publishing SSH threat reports because that's the only one that I'm doing really well so far. I'm building it out to try to do a bunch of other stuff, which I'll talk about in a little bit. Currently, it only includes the following information. You've got the attacker IP addresses, which I've got a shitload of, credentials that are being attempted, which is actually pretty cool. If you're an operator, if you work in offense, I've got some pretty sweet word lists that you can use. I mean, they're great for like password cracking. They're awesome because they're tried and true by these bad guys. They're using these passwords for a reason. They're using these passwords because they work. So if you're in offense as well, take the word lists from the passwords that I've looked at, take the user lists, and use those for what you're doing, maybe. And then the SSH library versions that are used, it's not really useful from a defense perspective, but it's kind of cool data. The Animus threat reports that I'm building look like this. This is the daily report generated by the Animus system on January 17th. Yeah, so this one was like yesterday. And so we've got, yesterday we had 250,000 attacks. These are the top 10 attacker IP addresses that we saw today. And then further down, it's going to talk about like we saw these passwords being used. We saw a trend of increased more by this much, whatever. This is, I've got data going back to October now at this point. And I've got, at this point, I think I have 5,500 unique attacker IP addresses that I've collected since October. And the number actually increases, I don't want to say exponentially, but the number has been increasing. It's been going up pretty fast, both between attackers like discovering my infrastructure and attacking it more, and them scaling up their attacks. I have seen stuff increase in the last couple of months. And so if you want to go back and look at the historical data that I was seeing, how it was different in October to how it is now, it's also been that I've been adding more infrastructure because when you start doing this stuff, it's so addicting. Unrelated fun fact about GitHub, I didn't know this. This has nothing to do with anything, but I just learned that GitHub trusts your client's clock. So when you're checking something into GitHub, you can commit changes that happened in the past by changing your clock. I didn't know that, but that was really cool because I was trying to figure out like how do I get my reporting engine to go through and publish my reports for data that happened yesterday and the day before and the day before. So I wrote this like for loop that basically changed my system's clock by 1 day backwards, and then it grepped the logs for that date, and then it published it. But then I was expecting to see like GitHub, GitHub has those like little blocks of like how often you commit code or whatever. I was expecting to see one like really, really dark green block from like 100 commits or whatever, but it actually like went back and committed these all throughout like October, and I'm like, oh, the more you know. So anyways, fun fact. Yeah, I know. Developers are definitely going to exploit that. Yeah, man, no, I already did it. I don't know what you're saying. Code was done last week. Sorry. So anyways, the Animus system that I wrote is it's constantly mass scanning the internet to locate these Chulang C2s that I was talking about before. Once the C2's been located, it will connect to it and it'll start logging the DDoS targets that it's looking at. So as they put their infrastructure up, it's going to find it and it's going to connect to it. There's a really easy way to get around that. I'm not even going to say it because I'm afraid they're going to find it, but it has to do with like default port numbers. I published a alpha NSE script for looking at Chulang C2s. So if you have some boxes that you're already looking at, you can incorporate this into your Nmap and you can look at stuff like this. I built this thing called ThreatBot, which is actually like, he has a GitHub page, whatever. It has a GitHub page. I'm kind of attached, so I call him he. Don't judge me. You can tweet to ThreatBot on Twitter with one or more IP addresses, and he'll tweet back at you if that IP address, well, he'll tweet back at you no matter what, but if that IP address has ever conducted any attacks that I've seen, it'll tweet back with you with a little quick report. It'll say, hey, we've seen this many attacks from that IP address. We started seeing attacks on this day. The most recent attack we've seen is this day. Right now, ThreatBot is only hooked up to like my last like 2 weeks of data, so it's not a ton of stuff. You can tweet at him and like you can check if it's like a big attacker, then he'll report back to you and you may be able to see something. I have like 6 months of data that I haven't incorporated into the same database that he's looking at. I need help with that. I need to find somebody who knows MongoDB and Nymacine better than me. If you fit this description, then please hit me up because I suck at that kind of stuff. He also tweets daily statistics of how many attacks we've seen and the IP address of today's top attacker. So if you're interested in that kind of crap, you can follow him on Twitter or whatever. This is what the reports look like. That's HK-47 from Star Wars Knights of the Old Republic, if you're as nerdy as I am. And then you can tweet at him, and he'll tweet you back. I actually built like a kind of a cool regular expression thing for IP addresses. You can tweet at him with like 5 IP addresses, or you can write like gibberish and then IP addresses, and he'll filter it out, and he'll do the queries and all that stuff. So that's kind of cool. So a couple defensive strategies. It's basically standard threat intelligence stuff, like whatever you want to do with the data. I mean, you can check for connections to, or you can block known C2s, which is a pretty standard thing. Flag connections to known malicious subnets, same thing. Look for connections to malware distribution web servers, like those HFS boxes that I was talking about before. You should never talk to those under any circumstance. So, if something is talking to one of those, it's probably bad. You probably got to compromise. You can check, standard indicator stuff, presence of files with MD5s or Yara signatures of known bad, of any of the malware that's collected. Defending against attacks on SSH, this is so easy. It's stupid easy. Use SSH keys, disable password authentication. If this is not possible for whatever reason, then you can audit, use strong passwords, audit against John the Ripper with the word list that I'm providing. You can blast it with Medusa if you want. Blast your own environment with Medusa with the password list that I provided and see if any bad guys could potentially get into your stuff if it's using password authentication. So roadmap of some of the stuff I want to do in the future, and there's a lot of this. My to-do list for this stuff just keeps getting bigger and bigger and bigger. The problem that I've actually run into is I did these slides in like 5 minutes because I keep working, like I wrote ThreatBot like 2 days ago, and like I have all this, like everything just keeps blowing up bigger and bigger and bigger, and I've got so much, like there's so many different things that I've been looking at. I'm like, man, I really need to start doing my slides like more than 2 days in advance. Recap real quick of just like what we've talked about. We talked about going from sensors to attacks, to malware artifacts, malware samples, to DDoS target leaks, to mass scanning the internet. We don't even need to capture samples to find C2s anymore, at least for this family. Conventionally, it's going to be like, oh, hey, I have a piece of malware, and I want to find the C2 for that piece of malware. And you still need samples to find C2s and stuff, but with this family, with this one thing that I've been looking at obsessively, you don't even need to have a malware sample that talks to that C2. You scan the whole internet. It's easy. People do it every day. You scan the internet in like 5 minutes if you use masscan and don't mind responding to abuse complaint reports that you're going to get a lot of. Here's some stats of stuff that I've seen. To date, I've seen 6,279,676 authentication attempts. I'm sorry? So this is over the course of 6 months, but that number, I need to graph it out properly. I've seen 2 million in the last 2 weeks. math, whatever. I've seen 5,500 unique IP addresses since October of 2014. I've seen 500,000 unique passwords being used. I've located a total of 30 Chulang C2s. I've identified 27 malware samples. That's right, that number is less than the number of C2s. Think about that. And I've leaked 750 different DDoS targets that belonging to 40 different organizations. And that's just in 1 month, because that is when I've started to get the Chulang logger working. Future plans, I want to build more signatures to identify different types of C2s. I know there are more C2s that use other things, other binary protocols and things that can be identified. Obviously, you're going to have HTTP stuff, you're going to have IRC stuff. It's going to be a little harder, but it's still doable. I want to expand ThreatBot's capability. I want you to be able to email him. I want you to be able to Pinterest to him. I want you to be able to do whatever you want. And I want to build out so he's got more data and he's got more things that he can report back to you with more useful information. Especially doing more things, I mean, other than just Twitter, just because maybe you don't want people to see the IP addresses that you're looking at. And I'm aware of this. I want to deploy more sensors because hell yeah, I want more data. I want to build automation for warning that DDoS attacks are coming. I want to build something that reaches out to the DDoS target's abuse contact thing, and I want to let them know, hey, you're probably about to get a DDoS attack. It's going to come from these people. I want to expand more stuff on with Shellshock and Heartbleed and other vulnerabilities that are being executed. I'm focusing really heavily on SSH right now just because the capability is already there. The attacks are happening. It's really cool stuff. I want to build an HFS web server watch script. So something that when I find known HFS malware hosting repositories or whatever you want to call it, I want to build something that reaches out and it looks at those all the time and it's always refreshing that and it's checking those, and whenever new malware goes up, I want to grab it. I want to improve the mass scanning and the dorking for HFS, so I want to be able to find more HFS. I want to find more of those HTTP file servers that host malware without necessarily looking at an operator, log into my box and reach out. I mean, it's 2015, you can mass scan the crap out of the internet, so I want to find it like that. I want to automate the automated signature. I want to improve the automated signature generation. I want to be able to build Yara scripts or Yara signatures and things like that from malware that I get as it happens, as they come in. And I want to build more useful information into the Animus threat reports, because right now it's kind of trivial information that can help you, but it can't really help you. And there's so much more data to collect. I mean, there's so many different IOCs that I could look at. There are more web servers storing malware. There's more C2s sitting out there. There's a ton of stuff. So I just wanted to give some credit to ThreatStream, Jason. This dude has answered all of my questions with everything. The Kippo developers for developing something so awesome. H.G. Moore helped me with a couple of different things. I reached out to him and he responded. If you ever email him, he emails you back in 3 minutes. Doesn't matter when you do it. It's dude, what do you do with your life? Brian Baskin, this guy who helped me reverse some samples. Johnny Vestergaard, he's the developer of Nimacine, or Namacine, however the hell you pronounce that. The thing that sits between MHN and MongoDB. HTTP Feeds talks to it. It's an awesome database. It's really cool. Malware Must Die, because that dude is awesome. Rob Blotty is a buddy of mine. He helped me reverse some samples. I wanted to really say thanks to ShmooCon for having me. I came here for the first time when I was 18 years old, and I was so stoked, and because of it, I got my first job in security and all that stuff, so that's the reason why I'm here right now. And the Linode abuse team, they've been pretty nice to me with everything. They literally email me 4 times a day, and they're like, hey, we got more complaints. Gonna have to block these people, and I'm like, you got it. So I wanted to say thanks to all of them, and thanks to all you guys for coming here to my talk. If you guys have any questions, yes? The question is, do I do any log analysis on TTY logs to identify if this is a human or if this is a bot? No, that's a really good idea. No, I don't. That's a good idea. I'll look at doing something like that. Yes, question? The question is, can I share some of the dates for the targets? Oh, the names of the targets? No, I'm not going to do that. Sorry. But it's a good question. Any other questions? Oh, yes, right there. IPv6 yet? Any, IPv6? I don't have that capability quite yet. That's on the to-do list. Thank you, though. I mean, but really, like, what are you going to do? Like, you're not going to mask an IPv6. I don't know, but that's a good question. I should look at doing something like that. Yes?
What are you doing with regards to source IPs that are attacking? Are you doing any verifications to verify it is a compromised bot, that it's a known good site?
The question is, what am I doing with the source IP addresses that are coming in? Am I doing any verification to see if the things that are coming in or not are compromised or anything like that? No, I'm not doing anything like that. Sometimes I know somebody else who runs a project where he'll actually just turn right back around and he'll nmap the box and he'll look for like a web server and stuff, and he's had good results doing that. And that's something that you can do that I could do. I just haven't implemented it yet. This is all still pretty half-baked stuff that I'm still working with. Any other questions? Okay, good, awesome. Thank you guys so much for coming. My name's Andrew.